first permutation. Permutation is a order arrangement of object, whereas combination is a unordered selection of object. So mark the difference. Permutation is order, whereas combination is unordered. Order doesn't matter in case of combination. An R combination of elements of a set is an unordered selection of R element from the set. So we are selecting R elements from this set where order doesn't matter. Let's see one example. Example 15. We have a set having 1, 2, 3, 4. Then 1, 3, 4 is a 3 combination from this set. So from this 1, 2, 3, 4 we can select any 3 element that will be 3 combination. Like 1, 2, 3 is a 3 combination. 1, 3, 4 is a 3 combination. 1, 2, 4 is a 3 combination. So here 1, 3, 4 and 1, 4, 3 both are same because order doesn't matter, right? 3, 1, 4 all are same. So 1, 3, 4, 1, 4, 3, 4, 1, 3, 3, 1, 4 all are same as order doesn't matter. So the R combination of n distinct element denoted by CNR. Permutation we denote by PNR and combination we denote by CNR. C for combination, P for permutation. Now CNR also can be denoted by NR. Simply we write NR, that is for combination of NR, and this is called as binomial coefficient. Now example 16, C42 equals to 6. Means we have 4 elements, from that we can choose 2 elements in 6 way. Suppose we have ABCD, from that we can choose AB, AC, AD. So we select AB, AC, AD, then BC, BD, CD. So we can select 2 elements from 4 elements in 6 way. That's why C42 equals to 6. Now theorem 2, the number of R combination of a set with n element where n is a positive integer and R is an integer are ranged between 0 and n. CNR equals to n factorial divide R factorial multiplication n minus R factorial. What is the PNR formula? Permutation of NR, that is n factorial divide n minus R factorial, whereas combination of NR equals to n factorial divide R factorial multiplication n minus R factorial. So now proof of this formula, the PNR, that is R permutation of this set, can be obtained by forming the CNR. CNR is the R combination of this set. Means we can find the permutation. First we will select R element, then we can order that R element. So that selection of R element from n, that is CNR, and that ordering of R element, that we can do in PRR. So CNR multiplication PRR equals to PNR. First we need to select R element from n, that is by CNR, then we can order them, that is by PRR. Now this CNR will be PNR divide PRR, and we know permutation formula. So PNR equals to n factorial divide n minus R factorial, and PRR equals to R factorial divide R minus R factorial. So R minus R, that is 0, 0 factorial is 1. So it will be n factorial divide R factorial multiplication n minus R factorial, and this is our CNR formula, our combination formula. So R permutation equals to R combination multiplication order of R element, that we can do in permutation of RR. Now let's see some examples. Example 17. How many poker hands of 5 cards can be dealt from a standard deck of 52 cards? Also, how many ways are there to select 47 cards from a standard deck of 52 cards? So there are 52 cards, from that we need to choose 5 cards, and it is asking how many poker hand of 5 cards can be dealt from 52 cards, and the order doesn't matter. That's why we can apply the combination. C 50 to 5, combination of 50 to 5, that is 50 52 factorial divide 5 factorial multiplication 52 minus 5 factorial. So this 52 factorial you can write as 52 multiplication 51 multiplication 50 multiplication 49 multiplication 48 multiplication 47 factorial, and this 47 factorial will be cancelled. Here you can write 5 multiplication 4 multiplication 3 multiplication 2 multiplication 1. Now this 4 can be cancelled with 48, so it will be 1, 2, and this 3 can be cancelled with this 51, 1, 7, 2 can be cancelled with 52, 26, this 5 can be cancelled with 50, it can be 10, 26, multiplication 17, multiplication 10, multiplication 49, multiplication 12. It will be 2598960. 2598960 different poker hands of 5 card that can be dealt from a standard deck of 52 card. Next, there is another question: how many ways there are to select 47 card from a standard deck of 52 card? So that we can do in C5247. So 52 factorial divide 47 factorial multiplication 52 minus 47, that's equals to 5. So this 52 factorial divide 47 factorial multiplication of 5 factorial, this is same as this. So we can say combination of 52 5 equals to combination of 52 47. Both are same. Okay. So here also result will be same, 2598960. Now from this we can conclude a corollary, that is corollary 2. Let n and r are positive integers with r less than equals to n. Then c n r equals to c n n minus r. So combination of nr and combination of n n minus r, both value are same, both are equal. Let's see another example. Example 18. How many ways are there to select 5 players from a 10-member tennis team to make a trip to match in another school? How many ways we can select 5 players from 10 member? So it will be C10 5, combination of 10 5. So C10 5 equals to 10 factorial divide 5 factorial multiplication 10 minus 5 factorial equals to 10 factorial divide 5 factorial multiplication 5 factorial. So after simplification we'll get 10 multiplied 9 multiplied 8 multiplied 7 multiplied 6 multiplication 5 factorial divide 5 multiplication 4 multiplication 3 2 1 multiplication 5 factorial. So this 2 will be cancelled. Now simplify. Let 5 2 will be cancelled with 10. Now 4 8 2 3 9, here 3. 3 multiplication 2 multiplication 7 multiplication 6. It's 252. 252 way we can choose 5 players from 10 members. Today I discussed combinations with some examples. Combinations is a unordered selection of objects, whereas permutation is a ordered arrangement of objects. In next lecture I will discuss some more example of combinations. If this lecture is helpful for you, please like, share and subscribe. Thank you.